Hi everyone, good morning, and thank you for joining us. Today we are going to talk about CPU and OCS I/O CAN wiring, and the presentation should last around 20 minutes. As always, if you have any questions, please add them in the question panel and we will go through them at the end. That said, let's get started.
Hello and welcome to today's webinar. Today we will look at CPU and OCS I/O CAN wiring. Let's take a look at our agenda for today. We are going to do a quick review of CAN port functionality. Mainly we are going to be talking about I/O expansion. We are going to talk about different types of connectors for CAN that are used on Horner controllers. We are going to talk about different types of wiring you can use for CAN with Horner controllers and Horner I/O. We will talk about making those connections, and there will be demonstrations throughout, and we will finish with a Q&A session. Let's do a quick review of CAN. Now, what is CAN for those of you who are unfamiliar? CAN stands for Controller Area Network, and it is a specialized chip that was invented many years ago that enables robust and reliable communications. Now, it is very popular in both industrial automation as well as automotive. Some of the chips are dedicated. Some of the chips have this functionality included in microprocessors and microcontrollers. Now, why do we need CAN in a world of Ethernet? Well, CAN is more simpler and more robust than Ethernet and requires less bandwidth, so it definitely has its place both in automotive as well as industrial automation, and at Horner we utilise it thoroughly. How does Horner utilise CAN? We primarily use CAN for two functions: easy I/O expansion for all Horner systems and peer-to-peer communications between Horner controllers, and to accomplish that we invented our own protocol on CAN called CSCAN, and it has been around for a while. It is very easy to use and very robust, and as a matter of fact, you do not even think about the protocol. You just connect up your I/O and use it, or connect up your controllers and have them start exchanging data. Now, in addition to I/O expansion and peer-to-peer communications, Horner also supports some standardized CAN protocols, including CAN Open J1939. CAN Open is an automation standard very popular for things like servo controllers. J1939 is an automotive standard, and we have plenty of customers that are using Horner controllers in either their factory to test their mobile devices or even on mobile devices themselves. Now let's start talking about how you can make that connection with CAN on Horner controllers. We're going to start with the connectors. Horner controllers have two different style connectors that they use for interfacing with CAN, depending on the controller. Let's start with open terminals. Open terminals is the most flexible way of connecting CAN in that you get a terminal strip included right on this CAN port on the Horner OCS or on the I/O block. In the case of some of our I/O series, and in most cases, it is a double plug like you see there on the screen at the upper left. So you can easily make connections for CAN coming in and CAN going out. So that is included in a lot of our products. Some of our newer products and some of our products that are physically smaller. Instead of using open terminal block, which takes up a little bit more space, they use an RJ45 jack, which not only facilitates smaller spaces, but it also facilitates using category style cabling or Cat5 or Cat5e style cabling with CAN, and that reduces cost and reduces labour. Now, which Horner controllers use which connector? Well, you can see that the Canvas and the XL Prime series, along with our traditional XL series, they use open style connection, and then the Micro series as well as the OCS I/O and the new CPUs, they use the RJ45 approach. So that is a quick breakdown visually for which controllers use which connector. Now let's start talking about cabling, because not only are there two different connectors that Horner uses with CAN, there are also two different cable styles. Let's start with CAN specific cable. So this is cable developed specifically for CAN, and there are some different variants, but all three variants were designed for CAN. Now what does that offer you? Well, it gives you the most robust solution to take advantage of all the noise immunity that CAN offer, and gives you clearly defined specifications for distance and the number of nodes that you can put on a network and baud rate. So you get a lot by using CAN specific cable. However, not all applications need that extra capability, so that is where category cable comes in. This is more convenient, easier to install in a lot of cases. Although it does have more limitations, it does not have the distance capability or the number of nodes. Now when we take a look at the conductors and the pin out for two different types of CAN cabling, let's go through that now. So when we are talking about CAN specific cables, we are talking about 5 conductors. We have a red and a black wire that can be used for power delivery when used as a pair, and then black wire or the V- conductor is also used for common mode reference, because these nodes can be separated by some distance, and also have a blue and a white pair. That is the actual CAN communications pair. Now we did not mention this before, but the red and the black pair is twisted, and the white and the blue pair are also twisted. Now in addition to that, you have a shield drain, which is a bare conductor that has to be handled properly in order to achieve those noise immunity that shielded CAN specific cable can offer. So this is CAN specific cable, 5 conductors. Now in the case of the Cat5 or Cat5e, when you are using that with CAN, you are talking about 3 conductors. We do not have the power conductor because we do not distribute power over Cat5 or Cat5e with CAN. We also always use unshielded Cat5 or Cat5e, so there are no shields to deal with as well. We just have the CAN pair, CAN high, and CAN low, which is the orange pair when we are talking about category Cat5 or Cat5e wiring. And then there is the common reference or green, white, and the V- pin. So even though there are 8 conductors with that cable, we are only using 3 of them, the orange pair, which is 2, and the green-white reference, which is 3. Now let's talk about some of the limitations with the 2 different types of cable. Now as we mentioned before, with CAN specific cable, there are 3 different variations. So depending on the variation, you get a network distance of either 100 meters, 300 meters, or 500 meters. And you have as many as 64 nodes per segment. And you can also use repeaters to expand the number of nodes up to 253. And you can do power delivery up to 4 amps. And from an EMI RFI noise protection, it is the best. Now if we look at the category 5/5E cable, which is always unshielded with CAN, the network distance is limited to 33 meters, which is still about 110 feet. We can do up to 8 nodes on that network. It does not provide power to deliver, as we mentioned, and it is an EMI and RFI protection because the conductors are twisted. So we get some benefit from that, but it does not have to be top level of EMI RFI protection that we have with CAN specific cable. Now let's talk about termination, because unlike Ethernet with CAN, when you are connecting devices over CAN, each physical end of the network has to be terminated with approximately 120 ohm resistor, And we have at Horner 3 different methods of doing that termination. Let's go through the 3 different methods now. So if you're using open style plugs, it is probably going to be convenient for you to use a physical termination resistor. And we include 2 in the box with every Horner controller that has an open style plug, and those are 121 ohms. So if you're using open style plug, that termination resistor might be the most convenient. Now if you're using a product that has an RJ45 jack, it is not easy to get a resistor in there, so we have added software termination. In other words, either within your program by turning on a system bit, or in your system menu by going into a specific entry in the system menu, you can turn on what we call a software termination. That is a software switch that puts a 121 ohm resistor into the circuit at the right place on the OCS. So that is the second method of doing termination. And then finally, if you have a Horner product that has 2 J45 ports on it for CAN and in and out, we now include an RJ45 terminator plug in the box for those products. That would be the OCS IO basis, for instance. Now we have not always done that, and you can also purchase these plugs separately if you choose, but it does come with the box now with OCS IO bases. Now let's talk about making those connections. Because we have got 2 different types of connectors and 2 different types of cabling, so the first question we get a lot is, if I am using OCS that has an open style connector for CAN, can I use Cat5 cabling? The answer is yes, you can certainly do that. And during this presentation, we are going to go through some scenarios in which you would do that, and we are going to show you how to do it. The other question we get is, can I use traditional CAN cabling with an RJ45 style jack on my controller or IO drop? And how do I do that? And again, the answer is yes. There are a couple of ways to do that, and we are going to show you in today's presentation. Now what we are going to do for the rest of today's topic is we are going to go through a few different installation scenarios and demonstrate on the bench how you might handle those from a wiring and connectivity standpoint. So let's start with our first scenario, which is a simple scenario. We have a signal control panel and we have got a micro OCS X7, which is the main controller for the machine, and we're using OCS IO inside the same control panel to expand the IO capacity of the machine, and any CAN wiring we have for the system is all internal to the cabinet. So that is our first scenario. So let's see how we handle that on the bench. So this is our simplest scenario that we have, where we have 2 components. The CAN wiring never leaves the enclosure, and both components support RJ45 for CAN. So we have got our X7 with its CAN port connected to our CNX OCS IO base connected to its RJ45 port. In this case, it turns out that a 3-foot or 1 meter RJ45 patch cable works well. And then we cannot forget about termination. In the case of OCS IO, we have got our standard termination plug, and in the case of the X7, we have either in logic or on the system menu, we need to turn on termination that is enabled in software. We only do that if the X7 is on the end of the network, which it is, and we only terminate the CNX if it is on the end of the network, which it is. Now for our next scenario, we have got a little more complex situation. This time we have 2 control panels and a main control panel housing the micro OCS X7, which is controlling the machine, and a second control panel with the OCS IO installed that is located remotely closer to where the sensors and actuators are located, providing the IO capacity for the machine. These 2 control panels are 25 meters apart, which is not too far, and we do not have any significant EMI or RFI concerns with the machine. So we are going to use category style wiring, Cat5 or Cat5e. So let's take a look at this scenario on the bench. For this remote panel, we are using Cat5 or Cat5e wiring from panel to panel, and we happen to be using bulkhead connector that has RJ45 on both sides. So on the outside of the panel, we have RJ45 connection. On the inside of the panel, we have a RJ45 connection. So we have got a standard patch cable, this time a 1-footer coming from the bulkhead connector to the OCS I/O base. And once again, we have our terminator plug to make sure this end of the network is properly terminated. In this scenario, we still have Cat5 or Cat5e coming in, but this time, instead of coming in through a RJ45 bulkhead, it is just coming straight through a traditional GLAN type connector to get cable entry. And the 3 conductors for CAN are just being landed on this field terminal strip. And we have got this pigtail of a RJ45 patch cable that we cut off and also connected to the field terminal strip. So in this case, again, just using traditional field terminals, we need 3 of them, one for CAN high, one for CAN low, and one for V minus in order to go with this approach for category wiring all the way through. Now for our third scenario, we have a very similar situation, but this time our 2 control panels are separated by a greater distance, and we have some concerns about extreme EMI and RFI in the application. So instead of using category style cabling, we are going to use traditional CAN cabling. Now when you are using CAN style cable, it is very important to handle that shield drain properly on the CAN cable. Now in this sort of application, the way we would typically handle that is we would ground the shield drain of the CAN cable usually at the main control panel, because that is usually where we have the best earth ground. Now if the better earth ground was somewhere else, we would ground it on that end instead. But either way, we would only ground it at one place only. Now let's go to the bench and take a look at how we make the connections. Now we are moving into some scenarios where we are going to start using CAN wiring as an interconnection between OCS and this remote panel. Now why might we use just traditional CAN wiring instead of Cat5 or Cat5e? Well, it could be because of distance. CAN wiring can go much further. It could because it is a tough noise environment for EMI or RFI. So in those scenarios, CAN wiring is superior. So those are a couple of reasons we might do that. Now one of the approaches we would take would be to bring the CAN wiring in through the cable gland and then connect it to the field terminal strip. And again, in this case, we have got 3 connections, CAN high, CAN low, and V minus. And once again, we are taking the pigtail approach into the CNX base with those 3 conductors connected to the interboson terminal strip. So this is one approach of solving that, and we have got another one. Here is the other solution we were talking about for interfacing traditional CAN wiring with RJ45, and that is this new breakout adapter or pigtail. It allows you to take 8 pins on the RJ45 port and break them out on an 8 terminal strip numbered 1 through 8, so that works nicely with traditional CAN wiring. Now in this case, we are not running power along with CAN wiring, we are just running CAN high, which is white, CAN low, which is blue, and B minus, which is black. Now it is feasible, and we could run up to 4 amps of power and take advantage of that red conductor in this cable bundle here. But if we did that, we would not connect the red cable to this terminal strip here. We would connect that red conductor to the field terminal strip, or maybe even directly to the front part of the CAN I/O base. So this is a different approach for interfacing traditional CAN wiring with RJ45. Now for our final scenario, we are going back to a simple situation where we have a single control panel with OCS all-in-one controller controlling the machine and the OCS I/O located on the DIN rail in the same enclosure handling expansion I/O. Now in this case, remember, the canvas features an open style connector for CAN. As we know, the OCS I/O features RJ45, so we need to interconnect those two inside the panel. One easy way to solve this is to purchase a cable from Horner that has already built that interconnection, an open style CAN port, an RJ45 style CAN port, and it is available in two different lengths, 3 feet or 9 feet. But you can also build this cable yourself by taking a standard RJ45 patch cable and cutting it to length and connecting it to open terminals block that's included in the box with your OCS. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly. Hello and welcome.
Okay, I'm back. So I'm not currently seeing any questions, um, at least for now. In this case, let me jump into the schedule. I hope you can see my screen now. So the next webinar is going to be on analog field calibration, and the other one is going to be on sizing WebMI for mobile device. And if you want to participate or are interested, please register on our website. Since we still don't have any questions, I believe that's all that I have for today. Thank you all for your time, and I hope to see you in the next webinar. Have a nice day, everyone.